All right, ladies and gentlemen. Okay, so good morning to you guys. Let's see. How'd you guys look at the work that we did yesterday? How'd you guys feel about that kind of stuff? Do you guys know? Was that easy? Was that hard? What do you guys think? The review? All right. Well, let's see. Looks like we have more review. How's that? So let me ask you guys here. We're going to have you guys. We're going to test your knowledge and see what you guys have. Let's actually double check. Yeah. Yeah. Okay. All righty. Bring these levels down. All right. Okay. So I'm going to have you guys do a little bit of warm up here. We're going to see what you guys know, what you remember. All right. Let's say here, solve for x, number 1. Okay, how about something like this? X squared equals 4. Number 2. X squared equals 9. All right, number 3. X squared equals, how about 20? Number 4, x squared equals 8. Number 5, x squared equals 12 here. And let's do something like this. Okay, and then I'm going to say something like this. Simplify the following. Number 6. Well, sorry. Take that back. I'm going to say this. Rationalize the denominator. Number 6, 1 over the square root of 2. Number 7, 1 over the square root of 5. Number 8, 3 over the square root of x. And number 9, 4 over the square root of y. Okay, so it's going to be a nice warm-up this morning. We're going to get nice and warm, see what you guys remember, see what you may have forgotten. But again, this is kind of a review, but it's not really an algebra. It's not really a geometry review. It's really an algebra review. But, we're going to do some review. It's going to be used part of our geometry review. You'll see what we're talking about. Okay, so we'll give you guys some time, and let's see how that goes. Okay. All right, ladies and gentlemen, let's take a look here. Hopefully we're all nice and awake. Anybody know what is this by any chance? Anybody know? What tool do you guys use to solve this equation for x? You got to know what you're looking at, right? And you go, what are you talking about, right? So if you have x squared equals a positive number here, right? Does anybody remember? What do you guys use to do this? What do you guys use to solve this? Because you're going to have two solutions. Is that true? How do you know you're going to have two solutions? Anybody know how you know you have two solutions always? Yeah, you see the power is 2? That means you have two solutions here, ladies and gentlemen. Okay? The power tells you the number of solutions. So, but what's the name of the tool? You guys want to even remember the name? Because, by the way, this is called a quadratic equation. Okay? But there's a tool that you can use to solve this very special type of quadratic. What's the name of the tool? Do you guys know? Has a name. You could use the quadratic formula, I will say, but I don't recommend it. You go, oh, it's even better. It's actually, this is a very special case, although you could use the quadratic formula for this. Right? Because it's always good. I don't know about you guys, but it's always very good to start thinking about language. Language is important. You know what I'm saying? Here's what I'm saying. If I say, do that thing, that drives me crazy. What thing are you referring to? You know, do that. That doesn't say anything. Is that right? You need to know a name of that. What is that? Okay? So here's the name you're going to use, ladies and gentlemen. The what? Square what? Root formula. All right? So you're going to get that language in you, the square root formula. Pretty good? Square root formula. Okay, now I'm going to go back to my browser here, and I'm going to say to you guys, where do you find the square root formula? Math 125 is called intermediate algebra. Intermediate algebra. Now, in Math 125, I'm going to go here. I got a bunch of worksheets and videos, and it's by name. I'm going to find this here. It's called the what? Where is it at? Oh, what do we name it? Square root formula. Isn't that pretty good? It's named the square root formula. So you go, oh, okay. Well, what is this? Well, this is a bunch of questions on the square root formula. Okay. And where is that thing? Where are you? Huh. Oh, it's hidden. I'm going to put this in the comment section. All right. There you are in the comment section. This is kind of what I go over in Math 125. And I also have, like, for example, video solutions for the odds for that kind of worksheet. So I'll put the link there too, in case this is something that you say, oh, you know what? I'm going to have to go back and take a look at some of this stuff, right? Maybe you want to take a look at that, and I got to find this comment section here. Okay, so there you go. Comment section. All right. Now, let me tell you what the square root formula is. Okay, I write it down as a fact, and you guys want to know this fact because there's a couple of nice facts here. If you have x squared equals p, and you might say, what in the world is, well, I'm going to do it this way. N. You might say, what in the world is n? So if you have this equals n, what does that mean? Got to move everything out of the way. If x squared equals n, what do you guys know? What does that mean? Then x is going to be plus or minus square root of n. Okay? This is called the what? The square root formula. Okay? Square root formula. You guys okay with that? So notice you got to know a couple of things here. First of all, you got to know the meaning of plus or minus. But then, even more so, you got to know how to take the square root of a number. Very important stuff, ladies and gentlemen. Square root of a number now. Okay? So, okay, square root of a number. So what does that even mean? Well, if x squared is 4, what do we know? That means x will be plus or minus the square root of what? 4. Okay? You guys okay with that? Now, here's the deal. Here's what I want to say to you guys. You got to know the square root of what? 4. And you got to know the square root of 4 without your what? Calculator. Yeah. And you go, oh my God, Mr. Judge, I can't do anything without that a calculator. Well, that's kind of like, I got to think of a really good analogy to all that. Square root of 4, you know, what do we say? Anyway, when I wake up, I'll think of a good analogy. Okay, so does anybody know what the square root of 4 actually is? 2. Good. It's the number 2. Is that right? Does anybody know how you know? How do you know square root of 4 is 2? Well, first of all, we know 4, this number right here, is called a perfect square. Is that right? So do you guys know what perfect squares are? Okay. So if you said, what's a perfect square? Well, a perfect square is anything that has been squared. That's a perfect square. That's the definition of it. So if you take 2 and you square it, what's the answer? 4. You guys okay with that? Now, what's the relationship? When you take the square root of 4, and this is what I get, this is what I teach in intermediate algebra. I say to students, if you have to take the square root, you want it to be the square root of a perfect square, because the answer here is the base. This is the base, ladies and gentlemen. Okay? So you're like going backwards. The square root of 4 was really 2 squared. The base is right here. The base is 2. So this is why your answer is 2, right here. Okay, so if you guys remember, but these have to be perfect squares. Perfect squares are anything, let's get the gold out. Anything that looks like that is a perfect square. So when you take the square root of it, you'll get, the answer is the base, is what we're saying. You want to know those things, because then you say, okay, well, what's my solution? Then the solution is going to be plus or minus what? 2. Now, what does that mean, ladies and gentlemen? Do you guys know what that means? Your solution is plus or minus 2. You guys know what that means? It's positive 2 or what? Negative 2. Okay? That means that there's 2 answers, positive 2 and negative 2. You solved a quadratic. There you guys go. Notice, was that better than using the quadratic formula? Yes. Okay, a lot better. Let's get my water. All right. So now you say, do I have to do that for the rest? You sure do. You sure do. And I'll just do, what will I do? I'll just move this one here, okay? So if x squared is 9, what do we say? By the square root formula. What does that mean? X will be what? Plus or minus the square root of 9. Do you know what the square root of 9 is? Remember, how do you write 9? Isn't that 3 squared? Right? So you say, oh, I know what that is. That's plus or minus 3 squared. What's your answer always going to be? The base. So the base here is 3. So we say x is plus or minus what? 3. How many solutions are there? 2. It means x is positive 3, or it means x is what? Negative 3. Okay, so it means you got 2 answers again. There's your 2 solutions. Set notation, we sometimes write it this way. I do that in a 125 course. So ladies and gentlemen, this tool is important to know, don't you guys think? You guys okay with that, right? And notice, did you reach for your calculator? Hopefully not. You want to know, you want to know how to take square roots. Yes. Yeah. Say that again for the test. Want you to.
Would you want us to write it out exactly like that?
Personally, I think it's good. I think it's actually. Let me say this. The short answer is no. It doesn't have to be written exactly as I do it. However, I do got to say that what I have learned as a student of math is that it's always good to do things the same way consistently. Randomness, ladies and gentlemen, is an issue. Randomness and inconsistency, I'll tell you, is something that I notice. So if you're kind of random with what you do and you're inconsistent, that's going to lead to errors. So I'm not kind of trying to encourage people to be OCD. You go, oh my God, that's OCD. No, it isn't. That think about how you learned how to spell your name. How did you learn how to do that? Anybody know? Every time you had a piece of paper, what'd you do? You practice it hopefully the same way every single time. And then what happens is you get better and better and better. You remember it. You know how to do it in your sleep. So, my advice to you just as a student of math is that try to remember that. Do it the same way. So if you guys see what I do, every single time I do that, I write it down this way. You say, why? Because it helps me remember. And so it'll help you remember. If you go, oh, x is plus or minus the square root of 9, right, going from here to here, right? That's just using that format I gave you. So you're reinforcing that fact over and over again, So that's what I do. So even when I lecture, notice, you might say, I hear a lot of complaints from students about instructors. You want to know one thing I hear? They don't show the what? Steps of the work. You know what I'm saying? And sometimes students go, oh, how'd you get that answer? Go, oh, that's just what it is. That's like horrible. You know what I mean? That's like what I would think when I hear that kind of drives me nuts when I hear people say things to me. Well, that's kind of like, without the explanation. So you want to get used to that. That's my advice to you guys. And that's what and that'll increase your accuracy. You now become more accurate with your answers if you do it the same way over and over again, showing your steps. So, but the short answer is, do I require it? No. Do I recommend it? Yes. And you say, why do you recommend it? Well, it's not, first of all, yeah, you show your work and that's important. But really the most important thing is that you are training yourself to get the right answers over and over again. A lot of it is just completely muscle memory. That's pretty deep. So anyway, ladies and gentlemen, yeah. But if you already know, oh, x is plus or minus 3, then sure, you can do that. All without a calculator, right? All right, number 3 here. So that's kind of the thing about, and that's the one thing, it's kind of ironic because that's the one thing I hear complaints from students about math instructors is they don't show me the what? The steps. You guys ever heard that before? You ever see that before? Yeah. What about tutors? Here's the answer. You say, well, how'd you get it? Well, this should give you some explanation. Hopefully. Anyway, I think the explanation is always the most intriguing, important aspect of anything. What's the explanation? You guys know what I mean? What's the story behind it? That's important. What about this? X squared is 20. Notice what I do. X is plus or minus square root of 20. And, I was such a student where I'd even write that thing down. Square root, what formula? That was me. And I even do it in red because you go, well, what are you doing? I'm reminding myself, oh, okay, that's the square root formula. And notice you got plus or minus square root of the what? Number. Is that right? Now, here's the problem, right? Is 20 a perfect square? No. So you might go, well, what do you mean 20 is not a perfect square? So what I do, and back in that class, I'd say take the base 1 and square it. Oh, that's 1 times 1, which is what? 1. Take the base 2 and square it. Oh, 2 times 2, and that's what? 4. Take the base 3 and square it. You're generating perfect squares. I ask those students to generate this list every day. And then I say, put that on the refrigerator. And then they say, well, why do I put that on the refrigerator? What do you guys think? How many times a day do you go to that refrigerator? Getting ice cream. Getting what? You guys know what I mean? Water. Getting whatever. Juice. I don't know. These are your perfect squares, right? And these are the bases. These are the answers. So you notice that 20 is not a perfect square. Is that true? And you go, well, how do I know for certain? Well, because these numbers are getting bigger, bigger, and bigger. Over here, these are all what I say is the perfect squares. So it's a good idea to know those numbers. That's in 125. Why would I know the numbers? Because now you have the answers to the square roots right over here. Is that right? Now these are all the answers. These are the bases. Remember that? These are the bases. And you notice that 20 is not there. But if 20 were to be there, you know where it would be? It would be between 16 and 25. Is that right? So now this helps me out. I know it's not a perfect square, but I'm going to say this to you guys. You want to know something? This is going to help me. I need to simplify that radical. And you go, oh my God, we have to do what? Yeah, you want to simplify your what? Your square roots. That's a square root. Also known as a radical in general. So you go, oh, Mr. Judge, I'm on that intermediate algebra page. Do you have anything like that here? Yeah, I do actually. Let me find it. Oh, simplifying what? Radicals. Look at this worksheet. I do this in 125. They got to learn how to simplify radicals. Why do you think they got to do that? Because it shows up in other classes. What class do you guys think that shows up in? This class? That's a good guess. Actually, it shows up in a lot of higher math classes. It's not just this class. So you might want to, sometimes if you say that to people, they go, oh my God, that's bad news, Mr. Judge. You mean it's going to show up in other classes too? I say, mm-hmm. Is that good or bad? No, it depends. I say be optimistic. What's optimistic? If you know it, then good, because you're going to use it over and over again. That's an optimistic explanation. Here's the video now, right? Here's the video on those worksheets. So this is, it started on that number. I'm going to put it in the chat because sometimes if you go back, you can watch it. It'll be in the chat, right? And I have somebody out there, even when it's face to face, there's somebody out there remotely. I can tell. I have a number here. So someone's out there. Don't know who it is. Sometimes they say hi and they put their hello in the chat. Anybody out there? Who's out there? Anyway. They're not saying hello. Maybe they want to go get some ice cream. I mentioned the refrigerator. So you can be optimistic. You might say, oh, I'm going to see it in other classes. So it's worth learning. It's worth reviewing. That's how I see it. And also, to give you guys some more advice, you want to get used to reviewing. It's going to just happen, whether it's in a math class or a science class. Get used to it. That comes with the territory. Everybody has to review. Everybody. I don't know if I told it to you guys. I might have told it to the calculus class. You know, Mr. Escalante, you know what he would do? He would like mess you up good. But that was back in the day. We weren't as sensitive as people are now. Or we couldn't be. Because even if we were sensitive and we complained, it wouldn't even matter, you know. So what he would do is he'd come in and he'd give you a pop quiz. And you imagine you showed up and I gave you this warm-up as a quiz. And I said, okay, turn it in. And you're like, what? What do you mean? Yeah, here's your quiz. Turn it in. I'm going to grade it and give it back to you. This is part of your grade. Oh, it's not on the syllabus. I don't care. Some kids would run out screaming. Couldn't handle it. You know what I mean? So you might have got a D. I missed all of them. Oh my God, I'm doing bad. So, you know, he graded. What do you think he was doing? Do you guys know? What do you think he was doing? What was that all about? I had to go through that. I'd show up in a pop quiz. They go, but that's not in the syllabus. You never told us. Well, that's the purpose of a pop quiz. It's a surprise. And you'd have to answer these questions. So you miss it, he give it back to you, and you're looking at your D. And you put a big old D on it. Or an F. People would just freak. Couldn't take it. But what do you think he was doing? Checking to see what you know. He's sending you a message. If you got a D or an F, go back and review this stuff. Because you're going to use it. That was his message. That was it. He didn't tell you that. But that's the idea. So what I'm saying is everybody's going to have to go back and review. Sometimes it's normal. I had to go back and review. So if I looked at that and go, oh my God, I remember one day I got a D on that quiz, right? And I'm like, oh my God, I got a D. What's going on? I had to go back and review the information that he quizzed us because that was part of what was coming up. You guys know what I mean? That was part of the course. So, I mean, and his little secret was he wasn't going to hold that quiz against you. He never told you that, though. He what was on the syllabus, he would hold against you. But those pop quizzes were not. And some students just couldn't handle it back then. They just couldn't handle the idea of you, of proving to them that you needed to review and do something, or you didn't have any knowledge, or you forgot, right? They couldn't handle that. It's a very interesting thing. So I remember people complaining, and he'd say, I don't care, get out of here, you could go complain. And, I guess people would or something, but nothing would happen, But it's kind of interesting, that strategy, Could that happen today? What do you guys think? All the things he used to say and do could never really happen today, I think. That's my personal feeling. People they would just melt, just heart attack. And you're only 16. You know what I mean? Heart attack at 16. You imagine? So I do warm-ups, and I remind people, how do you do the square root of 20? How do you simplify a radical? You guys see what I'm saying? See the difference? So there's a process. Do you guys remember the process? There's a process. You want to remember this. Give me the largest perfect square that divides 20 with a zero remainder. You guys know it's based on division, really. You go, what do you mean? These are all the perfect squares, 16, 9, 4, and 1. So when I teach that course, I say, okay, 16 goes into the number 20. Once, 1 times 16 is 16. Subtract, what's your remainder? Is that 4? Notice this is division. What am I saying? We need the largest perfect square that goes into 20 with a zero remainder. Well, it's not 16. What do? If it's not 16, what do you guys do? Go to the 9. Okay. Does 9 go into 20? It sure does. 9's the next perfect square. I need the largest that goes into it. 9 goes into 20 twice. 2 times 9 is 18. What's the remainder? 2. It's not 9. So you got to keep going. 4. Let's try 4. Go to the next largest. 4 is a perfect square. It goes into 20 how many times? 5. 5 times 4 is 20. Subtract, you got 0. Ladies and gentlemen, you're in business. Why are you in business? You got the 0 what? Remainder. You know what I'm saying? Yeah. You got the 0 remainder. What do you guys think? Now you say, well, how do I use this? You guys know the meaning of the word 5 there, or the number 5? Do you guys know what this is? First of all, I'm going to say this is the remainder. This is a remainder. This is your remainder. So we know the remainder portion for our division algorithm. What's the other number called? What's the name of the other number? Has a name. Remember, language is important. You guys want to know that too. Language. What's the name of the other number? Thank you. I got to get those flaming hots. Okay, got to go to Costco. Next time I'm on Costco, I'm going to remember get that big bag of flaming hots. These are the quotients. 5 is a quotient. So let's put this together, right? Here's what I mean by that. 20 is written how? I can write 20 as what? The quotient times the perfect square. In fact, I want you to do it the other way. Write it backwards. I want you to write the 20 as 4 times the quotient. Okay? So in other words, you're going to use the perfect square being 4, and you're going to use the quotient. Isn't it true that the number 20, this is what was under the radical, is written as that perfect square of 4 times the quotient of 5? So, you know, when I teach this, I show the students perfect square times our what? Quotient, okay? Now, this is what this means. We're trying to take the square root of 20. 20 is really 4 times 5. Do you guys notice that? 4 times 5 is 20. Okay? This is the process to simplify a radical. Now, I have to use another thing. You guys know what this is called? It's called the product rule. The square root of one thing times another thing is the square root of the first thing times the square root of the second thing. In other words, we use the product rule, and that procedure is what I'm using on that worksheet and those solutions. Okay, so you go square root of 20 is the square root of 4 times 5. So you go, oh, is that what you're trying to tell me? Yeah, by the product rule, square root of 4 times square root of 5. What do you guys know about the square root of 4? That's a perfect square. What's the answer? 2. So here's what I'm going to say to you guys. The square root of 20 is 2 times the square root of 5 when what? When simplified. Square root of 20 is what? 2 times what? Square root of 5. There's the process. What do you guys think? Pretty good? What have you said? Boy, I want to see more of these kind of things, right? Where would you see it at? Those website, the video, the resources I've showed you. Okay. Do you guys remember, anybody get this answer correct? Okay, good. Good for you guys. Good. Anybody miss it? It's okay if you've missed it. It's okay. Is that right? Well, if you missed it, what do you guys want to do then? Review that, right? You guys know what I'm saying? So we're not done yet, though, right? What do we mean by that? Remember what this is? Plus or minus the square root of 20. Here's what this is. X equals plus or minus 2 times the square root of 5. So there's two solutions. X is positive 2 times the square root of 5, and X is negative 2 times the square root of 5. So, ladies and gentlemen, those are the two answers. All right, you guys okay with that? By the way, if you guys really want to learn something, what's the square root anyway of a number if it's not a perfect square? Do you guys know what kind of numbers those are? What are the names of those numbers? They're irrational numbers, yes. Irrational numbers, yes. So, intermediate algebra in my mind is like learning about your number system. Irrational numbers are part of the real number line. It's important details. X equals plus or minus the square root of 8. But what do you have to do with the square root of 8? Remember this? You have to do what? Simplify. So, square root of 8, ladies and gentlemen, how do you simplify that? Do you guys know? What's the largest perfect square that goes into 8? 4. Good. What's the quotient? Good. Will any perfect square work? No, it has to be the what? The largest. Okay, you guys remember that? Has to be the largest. So then you use the product rule. So you have the square root of 4 times the square root of 2. What's the square root of 4? It's 2 times the square root of 2. So X will now be plus or minus 2 times the square root of what? 2. So what's the first answer? 2 square root of 2. What's the second answer? Negative 2 square root of 2. Here's your solutions here. Okay, you guys okay with those? What do you think? Not too bad? Easy breezy? Is it easy breezy, fresh and squeezy? I don't know. What's that phrase? Square root of 20. What's the next one? Was that number 4? Okay, this is number 5 then. X is plus or minus square root of what? 12. Isn't that the first step? Okay, what do you know about the square root of 12? That's not a perfect square, so we have to do what? Simplify. Okay, what's the largest perfect square that goes into 12? 4. What's the quotient? 3. Okay, square root of 4, square root of 3. What is that? 2 square root of 3. So X will be plus or minus 2 square root of 3. There's two solutions. What are they? The positive and the what? Negative. Okay, you guys okay with these? There you go. So notice this here, though, what I want to remark. Right? Square root of 4, you got to know about perfect squares. You got to know what the square root of 4 is. It's 2. Square root of 9 is what? 3. What's the square root of 25? Good. Square root of 36? 6. Square root of 100? Square root of 49? Square root of 64? Square root of 16? That's pretty much it, ladies and gentlemen. Square root of 1? Well, you won't see that in this context, but it's good to know. Square root of 1 is 1. So those are the things that you really want to know. And again, in the 125 course, I have to show that to students. And I do tell them, put that list, generate that list, put it on your refrigerator, memorize the list, because you'll be using it for the rest of the semester, right? But it's true. And it's not just that, you'll see it in your future. You'll see it even in science classes. They deal with irrational numbers even. Okay. Now, what about this other situation of rationalizing the denominator? Remember I said you're dealing with the most part irrational numbers? Do you guys know what I'm saying? You got two kinds of, well, you got rationals and you got what? Irrationals. You ever hear the phrase that you're being irrational? Or you're being rational? You ever hear that? What's being irrational? Anybody know? What's the definition of irrational if you took your favorite class, which is psychology or something, right? Any psychology majors? You guys know what I mean? Favorite class. Square root. Second square root of 2. This is an irrational number. Let me demonstrate this to you guys. You see, irrational numbers, so you guys know, are numbers that can be written, well, first of all, they have non-terminating decimals. The decimals go on forever. And then there's no pattern to what you see. So like the square root of 2 is irrational, and you might say, oh, Mr. Judge, that digit on the, in the calculator just ended, so what's the deal there? Well, it ended because of the fact that there's not enough space, there's the accuracy of the calculator. But that would go on forever. Is there a pattern to the digits? No, so guess what? It's irrational. So what about rational numbers? What's a rational number? Do you guys know what a rational number is? It's a number that either has a terminating decimal, it stops, or if it has a decimal, there's a pattern to the digits you see. The very famous fractions, ladies and gentlemen, like 1 divided by 3, 0.33333333 forever. Is there a pattern to the decimals? There is, right? Okay. So fractions and irrational numbers, rationals and irrationals are what? They form your real number line. Okay, whatever. Now, what do they say here? Rationalize the what? Denominator. If you just put the number 2 or the number 7 or the number 5, that's rational. You can it has a terminating decimal, 5.0, or it can be written as a fraction, 5 over 1, which is 5. So those are, again, rational. So when they say to you, rationalize the denominator, right? Where's your denominator, by the way? At the bottom. So you're looking at that. That's irrational. They're saying to you, make it rational. Anybody know how to do that? Right? You guys know? Should I show you the logic again? Let me show you the logic. What's our time like? Do you guys know? I get so excited when I get to talk about details in mathematics. Time to get out of here. I got the wrong class here. Okay, we're good. Let me show you guys. Show you guys some logic. Okay, tell me if you guys agree with me. Is any number equal to itself? Say yes. Good. Okay. Is any number times 1 itself? Okay, good. This is the logic, ladies and gentlemen. Triangle over what? Triangle. Isn't that 1? So in other words, I got to put something here on top and bottom, written as a fraction, that's going to make my denominator rational. Okay, you guys with me on that? It makes that bottom rational. Does anybody know what that's going to be? It's the exact number you see where? On the bottom. You go, it is? Yeah, it's square root of 2. Square root of 2. So if you do that there, you're going to say what? Square root of 2 divided by the square root of 2. Now, you're looking at 2 fractions. How do you multiply fractions? You guys know how you multiply fractions? It's horizontally across. So that you have 1 times the square root of 2 over the square root of 2 times the square root of 2. Now, remember that product rule on the bottom? Yes. Oh, thank you. Thank you so much. Thank you so much. Good job. I got into writing that email. 1 times the square root of 2 is the square root of 2. What's the square root of 2 times square root of 2 by the product rule? Do you guys remember that? You say that's 2 times 2, isn't it? You say, oh, is that the square root of 4? Yes. What's the square root of 4? 2. So, ladies and gentlemen, you are looking at the equivalent answer. So, what I'm saying is this is the square root of 2 over what? Square root over 2. So, this here is what you have. There it is. Is the denominator rational? So did you do what they said? Rationalize the denominator? Yep. And then that's the process. I want to go back here really quick because what I really show as well, students, and I'll remind them, hey, if you have the square root of a triangle times the square root of a triangle, right? That's the triangle itself. There it is. Number what? 7. What do you think you guys can do here as a shortcut? Top and bottom by the square root of what? 5. Is that right? You guys okay with that? Sometimes students say, Mr. Judge, do I have to go through all that detail, right? Well, only when you first learn it, but could you go straight to this? Can we just do square root of 5 times square root of 5? You guys know what I'm talking about? And what do you get? What do you get on top? Square root of 5. What do you get on bottom? And is the denominator rational? And you're done. Number what? Oh. Number 8. What about this one? See if we can do it up here. What if it's a letter? What do you guys think we can do if it's a letter? Can I do the same thing? What will that equal? Okay, the radical's gone from the denominator. What about number 9? What do you think? What do you have here? Let me go back here. We're going to do what? Multiply top and bottom by the square root of y. What do you get here? 4 square root of y over what? Y. There you go. There it is. Should we test you guys? Should we give you that quiz now? Why do we care? What are you guys looking at here? What's this called? You see this little square? What does that mean if I put that little square down here? That's called a what? That's a right angle. What's the measure of a right angle? 90 degrees. Good job. So you're looking at what we call a right what? Triangle. For a right triangle, if they said to you, hey, you see this distance? I'll call that distance D. I can call it X. I can call it whatever I like. Any letter. Why did I call it D? Why is it a D? You can say distance, but I'm calling it D for diagonal distance. It's called a diagonal. What's a diagonal? It's a line segment there that's not what? Horizontal or vertical. That's a diagonal. Do you guys notice something here? What is the meaning of these numbers if you say down here, this has a value of what? 2, right? What does that mean? 2 units. This is a value of 3. What does that mean? 3 units. Okay? So you're trying to determine diagonal distance. Is that kind of common sense if I said to you, do you guys know something? That what really bothers me in some ways is that if I said to you this question here, right? I used to ask students this all the time. Said this distance is 1. I'm drawing these boxes, right? This is 1. This distance is 1. So that you have a corner. And I'd ask students, hey, what's that diagonal distance, right? And I've done this, I've asked people this question for years. I used to teach this course at Cal State LA, not this course, a course called Math for Elementary School Teachers. So I used to actually ask those elementary school teachers, hey, I want you to answer this question. Can you guys tell me? Here's these dots here, right? This is called it's a unit diagram. Horizontal distance is 1, vertical distance is 1. What's that diagonal distance? What do you guys think? What's the diagonal distance? You guys know? What kind of answers do you guys think I'd get? 1. And I'd say, wrong. Wrong button. No, it's not 1. What's another answer that you think I'd get? I'd get the answer 2. And I go, no, the answer's not 2. You guys know what I'm saying? 1, 2. I get elementary school teachers guessing what the answer is. It's 1, it's 2. It's not. It's not at all. So what's that diagonal distance? How did you get the answer square root of 2? Huh? You guys remember? You got a very famous theorem. Pythagorean what? Theorem. And it only applies when you have a what? A right triangle, yes. So they have A, B, and C for the Pythagorean theorem for a right triangle. Here's Pythagorean theorem. Okay. A squared plus B squared equals what? C squared. So that's from geometry. Do you guys remember? So, okay. And so in this context, you might say, does that mean that d squared is 1 squared plus 1 squared? It is. D squared is 1 plus 1. It is, because we could do arithmetic, right? Or d squared is what number? 2. So what do you think you do now? Yeah, square root what? Formula. Square root formula, ladies and gentlemen. So in other words, d is plus or minus the square root of 2. You say there's 2 answers? Well, from algebra, there's 2 answers. Okay? Algebraically speaking, there's 2. But what could you do? Or what should you do? You get rid of the what? The negative answer. Why? It's a very good reason. You don't do that in algebra, though. But why do you do it in geometry? It's a very good reason. Yes, there's no such thing as negative distance. Outstanding. Good job. We're the Flaming Hots. No such thing as negative distance, ladies and gentlemen. That's the reason. Only positive distance. But algebraically speaking, if it was an intermediate algebra course, you got 2 answers. But in the context of physical distance, you got to get rid of the second solution. Isn't that wild? It's pretty wild. So yes, this is why this distance is the square root of 2, an irrational number. So from ancient times, you were able to do what? Deduce diagonal distance, and it was an irrational number. That's fantastic. What do you guys think? You guys know what I'm saying? See why you need those numbers, those irrationals? You need them because they're a part of our reality. That's just insane, right? They're a part of your reality, irrational numbers. A lot of people are like, I don't care. I don't care about numbers. It's like, but that's diagonal distance. You guys know what I mean? It's kind of interesting to me. Something that fundamental people want to throw away. Square root of 2. What about this answer? Yeah. It's weird. Guess so. I want to move it. What is this? D squared equals what? 2 squared plus 3 squared. D squared is 4 plus what? 9. D squared is what? So what would D be? Square root of 13. So you say there's 2 answers, right? Which one do you throw out? You throw out the negative answer. So that diagonal distance is the square root of 13. Is the square root of 13 a simplified radical? It is. How do you know it's simplified? Because the largest perfect square that goes into it is 1. That's the tip-off. Largest perfect square that goes into 13 is 1. That means the square root of 13 is a simplified radical. You can't go through the process. So there you guys go. This is a square root of 13. What do you think? Is that pretty simple? Okay, isn't this geometry? Is that some geometry, ladies and gentlemen? What do you guys think? Not bad? Anybody here forget all of this? Then it's good to have a review. Is that right? It's good to review. Anybody here, you go, oh, I know all this. I remember all this anyway? Mm-hmm. Should we test you guys? Still review, is that right? So, okay. What if they did this to you? They said, this is 2, and this is 6, and this is B. And let's say, determine the what? The missing distance. Right? That's always a very popular thing. What do you have to use the Pythagorean theorem? You have to see that square. It has to be a right triangle. That has to be 90 degrees. Okay, Pythagorean theorem only applies if there's a 90-degree angle. So then now, what do? You say what? 6 squared is what? 2 squared plus b squared. 36 is 4 plus b squared. 32 is b squared. B squared is 32. So what would b be? Plus or minus square root of what? 32. Okay, and you say, you know what? What can you do with this? There's 2 things we can do. Yes, we want to throw out the negative answer. Bless you. But square root of 32 is really what? Largest perfect square that goes into 32, isn't that 16? And then you have what? Square root of 16 times square root of 2, isn't that 4 square root of 2? So what is my distance? Isn't that 4 square root of 2? Do you guys remember these kind of questions from geometry? Right? You should have seen these kind of questions. That's 4 square root of 2. What do you guys think? Is that okay? What was I looking for? What am I looking for? Oh, looks like we have some time. Actually, I'm sorry. I'm looking at the wrong class. What time do you get out of here, you guys? 35? Oh, we're already out? No wonder you guys are getting antsy. Where are you going? Where could you go that's not better than this? All right, here's what I'm going to say to you guys. If you go over to the website, right? No wonder I was looking at 125. I was looking at the wrong class. Missed it. What do you think? Should you guys review taking square roots? What do you guys think? Should I put your homework in the Canvas section? I'll just put that. I'll let you guys go. And so we're out of time. Take care. Stay safe. I'll see you tomorrow morning. And have a wonderful day. All right.